Hello and welcome to my PowerPoint over shielded twisted pair cabling. I'm going to talk about understanding the basics and applications of STP. What is STP cabling? STP cabling is a type of network cable consisted of copper wires twisted together, each surrounded by a conductive shield, typically made of foil or branded wire. The purpose of this is the shielding helps to protect the cable from external electromagnetic interference and reduces crosstalk between the pairs, ensuring cleaner signal transmission. STP's importance in networking is first, STP cables provide superior protection against EMI and crosstalk compared to unshielded twisted pair cables. Another thing is they're ideal for high interference environments. They are beneficial in environments with significant electromagnetic interference, such as industry settings, medical facilities, and areas near radio electronic installations. Next, they are good for securing networks. Due to the reduced susceptibility to eavesdropping from EMI, STP cables are often used in securing networks such as those in governments or financial installations. They are also good for long cable runs. The shielding in STP cables is beneficial for longer cable runs where signals degradation and interference are more likely. Next, I'll talk about the structure of STP cabling. These are the components that are in STP cabling. One of them is just twisted pair wires. The twisting of the wires help to cancel out electromagnetic interference from external sources and reduces crosstalk between the pairs. This ensures a more readable and cleaner signal transmission. Next is the shielding material. The shielding, which can be made of foil or branding wire, surrounds each pair of twisted wire. It provides an additional layer of protection against EMI and radio frequencies interference, RFI for short, further enhancing the integrity of data being transmitted. Next is the type of STP cabling. There are 6 types of STP cabling: Cat5, Cat5e, Cat6, Cat6a, Cat7, and Cat8. These are the 6 different STP cabling. Now, the differences is the speed, frequency, and applications. The speed higher category cables support faster data transmission rates. Next is the frequency. Frequency higher category operates at higher frequencies, allowing for greater bandwidth. Now, the applications. The choice of cable depends on network requirements, such as speed, distance, and environment. For example, Cat6a and Cat7 are preferred for environments with higher interference with interference, while Cat5e is sufficient for most residential setups. The advantages of STP cabling. One advantage is they reduce electromagnetic interference, as I've talked about before. The shielding in STP cable helps block external interference, making it ideal for environments with higher EMI. Next is their better performance in noisy environments. STP cables are more effective in maintaining signal integrity in areas with significant electronic noise and such as industry settings. Now, comparison between STP and UTP. One big thing about the STP cables are additional shielding, foil, branding, radiated mass around the pairs, wires against electromagnetic EMI, crosstalk. They have better shielding than UTP. UTP cables lack additional shielding, relying on the twisting of the pairs to reduce interference. Next is their performance. They offer better. STP offers better performance in environments with high EMI, ensuring more relatable data transmission. Readable data transmission. Reliable data transmission. Yeah, sorry. Now, the performance of UTP is suitable for environments with low EMI. They are more prone to interference compared to STP. Now, one big reason that STP is compared to UTP is the cost. Generally, STP is more expensive due to the additional shielding material, while UTP is cheaper because it has less shielding on it, which makes it more likely to get and have interference with them. Next is the installation. Heavier and STP is heavier and less flexible, making them more challenging to install. They also require proper grounding. While UTP, they are lighter, more flexible, and easier to install. They do not require grounding. Next is the use cases. Ideal for industry settings, data center, and areas with high EMI. That is STP. Now, user cases for UTP is commonly used in residential and office networks, where EMI is minimal. Next is the disadvantage of STP. The disadvantage of STP is mostly the higher cost. STP cables are generally more expensive than unshielded twisted pair UTP cables due to the additional shielding materials. And next is they're more difficult to install compared to the UTP, which can be difficult in its own right. Next is they'll need grounding. They are required grounding. Proper grounding is essential to prevent shield from acting as an antenna picking up unwanted signals. Next is the maintenance complexity. Maintaining STP cables can be more challenging due to the needs for proper grounding and potential for damage to the shielding. Next is the high antenna rate. STP cables can have a high antenna rate, which may affect signal strength and overall long distances. Now, the applications of STP cabling. Next, the first application is data center. STP cables are ideal for data centers where high data rates and minimal interference are crucial for maintenance, reliable network performance. Next is industry environments. These cables are commonly used in industry settings where machinery and equipment generate significant electromagnetic interference. The shielding helps protect against the interference, ensuring stable data transmissions. Next is high-speed networks. STP cables are suitable for high-speed networks applications such as gigabit internet and beyond, where maintaining signals integrate over long distances is essential. Next is medical facilities. Hospitals and medical centers often use STP cabling to ensure reliable, readable data transmissions in environments and sensitive electronic equipment. Next is airports and government buildings. These locations benefit more from the enhanced security and reduced interference provided by the STP cable. Next, the installation and maintenance of STP cabling. The first thing is proper grounding, essential for performance. Ensuring that all STP cables are properly grounded to prevent the shield from acting as an antenna and attracting interference. Next is consistent grounding. Maintaining consistent grounding throughout the network to avoid potential grounding loops. Next is the handling and installation tips. 1 is avoiding the essential binding. Handle STP cables with care, avoiding excessive binding of twisting, which can damage the shielding and affect performance. Next is shielding termination. Use appropriate connection and ensure a termination to maintain the integrated of shield. Cable bonding. Avoid bonding STP cables tightly, as it can create crosstalk and unpaired signal transmission. Next is labeling. Clearly label all cables for easily identification and troubleshooting. Next is maintaining ensuring optimal performance. Regularly inspect cables for a signal of damage, wear, or degradation. Replace any damaged cable prompt to maintain network performance. Next is clean connections. Ensure that all connectors and ports are clean and free from dust and debris to prevent connectivity issues. Next is monitor performance. Use network monitoring tools to keep an eye on performance metrics and identify potential issues early. Now, the conclusion. In conclusion, the future trends innovation in cabling technology. Now, fiber optics. Increase additional fiber optics cables for higher data transfer speed and longer distances. Power over Ethernet PoE, growing uses of PoE to power devices like IP cameras and wireless access points throughout the same cable used for data transmissions. Now it's monocule systems. Development of monocule cables systems that allow for easier upgrades and maintenance. Electronics efficiency. Innovation aimed at reduced power consumption, improving the energy efficiency of network cabling. Next is the coexistence of cable and wireless. Integration of wired and wireless technologies to provide more flexible and robust network solutions. That is all for my things. So, thank you. This has been my PowerPoint presentation over SDP. And thank you. I'll talk to you next time, I guess. I'm done.